Okay, we're going to begin by talking about what density is. And density is going to be given by the letter rho. So I know it kind of looks like a P, and it's one of these things, and it's the Greek letter R. So it's row, as in row, row, row your boat. And so our definition of what density is going to be is it's the mass of an object M and then divided by its volume V. And notice that I put some hooks on the V, and it is a capital V. And the reason why I do that is because we've already used lowercase v for velocity, and then we also had something that looked like this, and that was called nu, and then that stood for the frequency of a wave. So it can get very confusing when you start making symbols like this. So I make a capital V and then I put some hooks on it. You don't have to do that if you don't want to. But density is going to be how concentrated a mass is. So you could, for example, take a piece of paper and you could wad it up into a ball. That piece of paper has a certain mass M, and then it would have a certain volume V. If you then take that ball and you make it even smaller, you are going to be increasing the density of that paper when you do that. So notice that as the V gets smaller, and it's in the bottom part of the formula, then the density gets larger. So I would like for you to be able to solve a simple question like this. How do the density of these two objects compare? So notice that they have the same volume, they're in the same cube, but they have differing amounts of mass. So notice in the first box there are less green things in there than there is in the second box. So if our definition of density is mass divided by volume, and if the volume is not changing but the mass does, then the one that has the larger M is going to have the larger density. Okay, for part B it says, how do the density of these two objects compare? Now this time, both of those cylinders are going to have the same mass. They have the same number of yellow particles in there. So we're going to say that they have the same mass, but you can see that they have a different volume. So the M is going to stay the same, but notice that for the first cylinder, it has a large V. And so when you divide by a large number, what comes out is going to be a small number. So therefore, the first cylinder there, the larger cylinder, is going to have less density than the second cylinder. Now here is one in which you're actually going to be plugging numbers into it. It says that a refrigerator has a mass of 113 kilograms, which is about 250 pounds. And it has a volume of 1.03 cubic meters. So a cubic meter is going to be 1 meter by 1 meter by 1 meter. And so when you multiply all that together, that's 1 cubic meter. But notice that the inside of a refrigerator is approximately 1 cubic meter. So what is the density of this refrigerator? So we know the M is the 113 kilograms. The volume is 1.03 cubic meters, and we need to solve for the density. So we're going to put the mass up here, put the volume here, solve it, and you get 110 kilograms per cubic meter. Okay. Here are some typical densities of objects, and so you can see that some objects are not very dense and some are. So air, for example, has a density of approximately 1. So 1 kilogram per cubic meter is approximately the density of air. The density of water is about 1,000. So 1,000 kilograms per cubic meter. So it's about 1,000 times more dense than what air is. And then you can see, like, for example, what is the density of a rock, and then what is the density of the nucleus of the atom. So you can just kind of compare densities of different objects. All right, we're going to take a break. When we come back, we're going to talk about the theory of elasticity.